Today we're going to be talking about how to complete a project in PVCAD. So first thing we're going to do is make sure that we have PVCAD installed. So we have a ribbon up here that is showing us all of PVCAD. Click Show Dialog so this dialog is available to us. And we'll go to Settings to make sure we're in PVCAD Optimization Type Standard for rooftop design. Next, I have open a template from PV Complete's website. You can see that this has a bunch of linked variables here, and it has a nice plan set layout for us. We can go ahead and enter our project name, number, and things like this here, or we can load them in from an Excel template that's also available on the PVCAD website. This will go ahead and enter these in here and automatically update our template for us. But we'll do most of our work today here in the model space. So we'll pop over here and we can see that we have a compass already waiting for us. And the first thing I'm going to do here is I'm going to run the units command. So I just clicked anywhere and I type units in. Here it's going to open up the drawing unit types for me. I'm going to see I'm working in inches. I'm happy with that. If you need to change it to feet or meters, you can go ahead and do that. But the important thing is to do this before we import any of the imagery data. So I'll click cancel here. And I'll just start setting my location. So if I clicked file here, I'd be able to import a KMZ or KML. So if I have some boundaries already defined in those formats, I can pull those right in. But for today, I'm going to go ahead and choose the map option. I'm going to go ahead and put an address in here. You could use also latitude and longitude or a landmark. And we'll go ahead and find that for you. So here's the building we're going to be designing on. I'll click OK. And this is going to pull the imagery in for us. And now what's going to happen is going to be an exploded version of this. I'm going to go ahead and use a quick couple hotkeys here. So I'm pressing Z enter for zoom and then E enter for extents. What that's going to do is it's going to just go ahead and zoom my model space out to the extents of anything in there. So if I go ahead and zoom in, I can start to design this roof here. So I will go ahead and use a polyline. So I'll go to Home, Polyline, and just go ahead and trace the outline of this building. I'm going to do this really quickly. Normally we'd be a little bit more detailed, but just for example's sake today, we'll go nice and fast. Now you can see that when I get to the end here, I have this box that's called a snap. So if I need to toggle that, if you're not seeing that, you can click F3 and it will toggle that on and off. You can see I just toggle it on and off. It's also down here in the corner, the snap button in the quick commands there. And then you'll see after I enclose it, it still has a tail. I just press enter and I go ahead and enclose that. We have some obstructions here. I'm going to go ahead and just create rectangles. So I use the quick command. I just started typing rectangle. Then I can copy and paste these as well. And I can kind of duplicate the effort across here for all of these that look like they're the same. Same thing with these smaller ones here. And then for circles too, we could do the same thing. We're just going to start typing circle, and we can go ahead and create that circle, starting with the center point. Now, if I need to move any of these, I just select it once. I can press M for move, enter, and I can now move these around as needed. I'm going to come out here. I'm going to select my imagery and just click Show Hide Imagery for now. A couple quick CAD tips. If I left click and I drag from right to left and I encounter an object in that selection box, you can see it's highlighting that object. So if I click here, it will highlight it. If I left clicked and drag left to right, it doesn't unless I fully enclose that object in my selection area. So see, I'm grabbing that circle object there once I fully enclose it. So you'll see that I'm going to be selecting things with those two different methods as we move along here. So quickly, I'll grab my roof out, and I'll go ahead and give this a height. Now these are unitless. We'll have to remember we are working in inches. I'll give it a slope of 3 degrees, and we'll leave the rest kind of alone here and just go ahead and define that roof. Now you can see a couple things happen. I had a shadow object created here. You can see up here it is registered as an AutoCAD layer, so I can toggle visibility states and things like this if I don't want to see those. I can also change the parameters for the shadow here in settings, and I can also rename the layers in the next tab as well. I'm going to leave those both alone for now, and I'm going to get on to defining some of my obstructions here. So these are all the same. I'm going to go ahead and define them as obstructions. I'm going to give them a height of 12 inches and a 2-foot setback. You can see that it cast that shadow and it created that setback for me. And then I'm going to go ahead and give these obstructions, I'll just give them a height of 4 inches, 3 inches. It's good. And then same with this pipe, I'll go ahead and say 6 inches. All right, so now I have my roof defined here. I can go ahead and start to put in some of my panels. But first, we're going to look at the version settings tab. We'll kind of work this left to right here today. So here we're going to put in what are our preferences for wire type, right, copper, aluminum, conduit type, and you can kind of work your way all the way down here, right? You can see if we have disconnect options, things like this. And one very important one, what's our interconnection? So here it's set to single phase. I'm going to change this to 3-phase, and I'm going to put in 208. But later on, you're going to see I'm going to put a 480 volt inverter in here, kind of as a mistake on purpose here, just to show you how it handles voltage differences. It's going to automatically put a transformer in there for us. Not that we'd ever have a 480 volt inverter interconnected to a 208 system, but just to kind of show you as an example. So here we'll go ahead and set those, and we'll come over to our mechanical layout tab. So here you see a couple different options: flat roof, carport, ground mount, slope roof. So for today, we'll be doing just a flat roof, but it's not so different for a slope roof. We're just going to be using maybe 2 peaks, and we'll be using rail systems instead of ballast systems. So for today, I'm going to go ahead and use one of the predefined racking systems. I'll go with EcoFoot 2. And then I'm going to pull in some panels here. This is our panel library. It's pretty all-inclusive. If you ever need a panel that's not in here, let us know, and we'll go ahead and get it in there. You can actually also insert it with the Database Plus button here. You can import a pan file pretty easily. The only problem with this is if you give this to a colleague, they won't have that panel in their local library. So we do suggest you work it through us if at all possible. There is this info button too that gives us a nice spec sheet. I like this because it's formatted the same for every single panel. So once you get used to it, it's pretty nice. You can see a lot of these other options are grayed out. If we had used a user defined, we would be able to go ahead and define these. You can see that if I hover over them, it does give us nice graphical representations of what each aspect is. But with that, we are ready to go ahead and start designing. You can see I often use the quick save command. That's just Control S. You can see if we make an edit, star appears in CAD saying, hey, we've made changes and you haven't saved it since then. When you quick save, that star goes away, so you know you're up to date. So here I'm going to go ahead and just make a layout. It's going to ask me what my azimuth is, so I can either put in what I want this to be, or I could snap it to an edge. And one thing I should have mentioned here, if I want my roof to be, right now the azimuth for the roof is 180 degrees, but if I wanted to actually set it along this edge, I can snap it here as well. You can see it changed it to 178 degrees. So now if I want to match my panels with this edge as well, I can go ahead and make this layout. I can put in 178, or I can do the same thing and I could snap to this edge, right? So that makes everything be in line. And now if I click anywhere within that roof, it's going to go ahead and place panels everywhere possible within the bounds I've given, right? So obviously there were other obstructions in the roof that I did not create, but here I can go ahead and edit single panels. So if I wanted to go ahead and delete panels, I just highlight them and I just click the delete key there. If I wanted to add those panels back in, I can use the add panels button here and I can go ahead and drag them in, right? If I wanted to click and drag in an open space, I would just use the click and drag button down in the bottom right instead, and I would be able to click and drag into an open space as well. But with that said, I'll say that I like my panel layout just the way it is. I won't alter it too much more. And I'll do a quick save here. And I'll go ahead and move on to my electrical layout. So here I'm going to have another library. So if I was doing maybe a rooftop, I could use some microinverters, maybe some N-phase, things like this. But for now, I'll do a string inverter. I'll go with a solar edge, and I'll go with a 480 volts inverter. Solar edge does need optimizers. It lets me choose which one I'd like. I'm going to just leave P500s in for now. I'm not 100% sure if that's correct. Obviously, we'd want to just go on Solar Edge's website and make sure those are the right ones. It's going to give us suggested string sizes here as well. So I can put in different sizes. You can see it's giving me a little cheat down bottom here as well. So if I alter this, it's going to tell me if I get to a perfect string size, right? Or I can go ahead and delete modules. So I'm going to leave this at 20. And there's a couple different ways we can string things. Directionally, automatic, and manually. So manual, we would be selecting each panel and then go ahead and click draw strings. In auto, I'm going to go ahead and use this for now. Oops. And this is a good error because I forgot to insert my inverter. So first things first, I'm going to insert this inverter. Now I should note where you put this matters in terms of the cable bill of material. So if I put it physically off the roof, it knows it needs to get that 300 inches down to the ground. So I'm going to go ahead and do that and say that we have these on the ground next to, or maybe affixed to the building. And then I'm going to go ahead and get to drawing my strings. So it asks me to select the objects. I'm just going to select everything and I'm going to press enter. And you can see it did exactly what it asked for. It's not the most ideal stringing, and it did end up with exactly those 5 modules left over. I'm just going to leave them here because I'm going to do a partial design to show us how to get there, how to get all the way through a project. So normally I would clean up these strings. I would use some variation between automatic and manual, but in this case, we'll just move ahead. So the next thing I want to do to get to an electrical design is I will get some source circuit conductors. So this is source in terms of the strings. So I'll just bring in a few strings here once I'm done selecting them. So it's prompting me here. It says select strings to connect with combiner box or inverter. Here I'm going directly to the inverter. If I wanted a combiner box, I could insert one, but when I've selected all the strings I want, I'm going to press enter, and then it says pick an alignment point. So where do these wires all want to come to? I'll just pick a point up here, and then it says select inverter or combiner box. I'll go ahead and just go right to the inverter. So it looks a little bit messy. It's a good time to remind that we can, once we're done designing here, we can toggle the visibility state of these, right? So if we're making a plan set and we need to clean these up for the paper space versions, we can go ahead and toggle that visibility and obviously toggle it back on. But for today, I'll just show you that. And again, normally now I would duplicate my inverters as much as necessary and kind of work with how many strings I need in order to create a full design. But I'll show you kind of one of each, so just to get you through the process, and then the rest is iterative. So the next thing I would need is I've now gotten my source to my inverter, and now I need my AC output. So I'm going to go ahead and insert an AC panel, and we need an AC panel at least in order to create a single line diagram. So once I have that AC panel in, I'm going to go ahead and need the AC conductor. So similar process to the source conductors. I'm going to press it, and it's going to go ahead and prompt me what to do. So I'm going to go ahead and select the inverter. Again, I would have normally duplicated this inverter. So I would select multiple inverters that I want to go to this panel. But when I have them all selected, I'll click enter. And then it's saying select the AC panel. I select that. And it's going to go ahead and create that conductor for me. Now at this point, I do have a complete system. Again, I haven't really designed the other half, but it would be an iterative process to do the inverters, if we wanted any combiners in between them and what. So at this point, I'll move forward and show you how we can get to the electrical. So once we have everything connected through to an output, I can go ahead and click the single line diagram button. And this is going to automatically do a couple things for me. Most importantly, it's going to draw that one line for me, but it's also going to do some calculations for me as well. So when it's done, you may have to scroll around a little bit, and you can see it has popped up down here for me. So here's the calculation tables, so we can see racking specifications, model specifications, things like this. These are very handy to put into various different paper spaces, things like this. And one of the things you can see here, just like I was saying, the inverter voltage and the service voltage, we have a difference here, right? So what happens is it went ahead and it created the strings. It knew I needed those optimizers, so it's showing those. It went ahead and did the sizing for me for the minimum copper wire that I had asked for. I can change how these look if I want to have a different looking block. I can also at this point add in different disconnects, right? So if I want a fused disconnect or an unfused disconnect, so I'll put in I'll put in an unfused disconnect here. Similarly on this side, on the AC side, I can go ahead and put in disconnect. So each one of these blocks you're able to add and change. If I wanted to change any of these text, I can just double click it and I can go ahead and change those as well. And here you can see what I was talking about, where I on purpose gave it a mismatch in voltage, and it went ahead and handled that for me, right? So it put in a 480 to 208 transformer for me. Now normally I'd go, whoops, I used the wrong inverter. But this was more of a way to show you how it would make sure that you have a seamless system here. Now, once we have this, we're able to also get a bill of material. And this is going to open up in Excel. And this is going to give us basic panel counts and things like this. And then we also have the availability to export this to a KML. I'll say PV CAD exam. And we can also, at this point, run a quick energy. This is going to go ahead and create an energy simulation for us. It's going to give us some nice monthly plots as well as hourly data. And once that's done running, we'll go ahead and click the yes button, and that should open up in Excel for us. And there we have the monthly plot. We have the raw data and the hourly data. And then finally, we have an export to PVCAD as well. So if we go ahead and click the PVCAD button, the gears will start turning here again. And what this does is it creates a zip file export. So within that zip file, there are 4 folder directories. Those folder directories, the contents of them can be brought over to the locally installed data directory for PVCAD. And once those are in there, they will be able to be opened nicely from there. So if we go ahead and export that here, you can see those folders. I'm sorry, the 3 folders, and those would go into the PVCAD data directory. And once you open up PVCAD, they'll be waiting there for you to look at in that software. So that is the full overview of a project cycle within PVCAD. If you have any questions, feel free to email us at support@pvcomplete.com. Thank you.